cyclic top is a series of regularly spaced top-type faults in the track. This type of defect can derail susceptible types of vehicles, even though individual defects may not look severe at first glance. The series of dips causes a buildup of stored energy in the train suspension. The energy within the suspension can only be released in one direction, by lifting the body of the rail vehicle up. As the track is not easily compressed, the path of least resistance is to lift the body of the train slightly, making the vehicle go light for a period of time. The principle of lifting the vehicle to dissipate the energy is only a short-term gain. When the vehicle gets to the top of the lifting phase, following a dip, it causes a lift-off effect. Gravity takes over, and the vehicle drops back down and lands at the bottom of the following dip, causing the suspension to compress. This introduces more energy into the suspension because two opposing forces are acting at the same time, gravity versus track rise. If the dips and rises are regular, the process continues, increasing the store of energy within the suspension. Eventually, this enables the whole vehicle to become airborne, lifting the wheel flanges over the level of the railhead. This means the train can leave the track and derail. An important consideration is with other circumstances, working in parallel with the lifting off of the wheel set. A severe twist, exactly where the wheel set is clear of the track, means that the wheels could miss the rails on landing and cause a derailment. Poor alignment could also have the same effect. This is why cyclic top and associated twist or alignment faults have a shorter rectification timescale. The trigger for cyclic top could be a dipped joint, IRJ, adjustment switch, S&C, or wet beds. As the vehicle travels over the dip, the vehicle rises and drops further along the track, which starts to compress the track ballast at that location, initiating the development of a new dip. If this continues, both the first dip or trigger and the consequential dip will get worse. If untreated, the combination of the first two dips will propagate a third dip further along the track, at the same distance as the distance between dip 1 and 2. Each section of track will have a predominant traffic type and vehicle speed. This means that a vehicle reacting to the trigger will generally land at the same point each time. Allowed to continue, the cyclic top will propagate and worsen, making the dips deeper and the number of dips increase. Cyclic top can be reported on the left rail, right rail, or as both rails. Single rail cyclic top is possible because there are situations where a trigger is only on one rail. The distance between each dip is called the wavelength. The wavelength is directly related to the predominant speed of traffic. For instance, a line speed of 60 miles per hour will generally have a wavelength of 13 meters. The slower the predominant speed of traffic, the shorter the wavelengths are that affect the trains. Cyclic top is recorded at 4.5 meters, 6 meters, 9 meters, 13 meters, and 18 meters because of the various possible speed profiles of all trains on the network. On the fault report, cyclic top will be reported with the number of cycles. The number of cycles reported is the number of dips at the specified wavelength beyond the trigger. Cyclic top is a theoretical value calculated by the TRV to represent the amount of energy potentially stored in the suspension, and is only reported when the value reaches a predetermined threshold and are categorized from Cat I to Cat D. When carrying out any repairs to cyclic top, it is important to rectify the trigger to prevent the fault from reoccurring. Repair timescales for cyclic top are detailed in Table 2 and A1 of TRK 001, Module 11.